Air pollution kills an estimated 7 million people worldwide every year. WHO data shows that 9 out of 10 people breathe air containing high levels of pollutants. In a world where the air we breathe is a silent canvas painted with the beauty of nature and the ominous presence of an invisible adversary, we find ourselves at the intersection of curiosity and concern. Picture this: a microscopic battleground unfolds within your lungs every breath you take. As we embark on this journey through the unseen landscape of pollution, let's unravel the story of these minuscule troublemakers, the dust, soot, and aerosols that dance in the sunlight, yet harbor the potential to cast shadows on our well-being. Join me in peeling back the layers of this microscopic saga, where the seemingly insignificant becomes profoundly impactful. It's time to delve into the intricate dance of particles and explore the profound influence they wield over the air we share and the breaths we take. Now we will discuss major contributors in air pollution. Firstly, particulate matter, PM. PM can contribute to haze, reduce visibility, and deposit in ecosystems, affecting soil and water quality. Secondly, nitrogen dioxide, NOx. NO2 contributes to the formation of acid rain, which can harm aquatic ecosystems, soil quality, and vegetation. Furthermore, sulfur dioxide, SO2. SO2 is a precursor to acid rain, which can harm aquatic life, forests, and soil. While not a major contributor to environmental pollution, high levels of CO can contribute to smog formation. In addition, ozone, O3. Ozone can damage vegetation, including crops. Furthermore, volatile organic compounds, VOCs. VOCs play a role in the formation of smog and can contribute to air and water pollution. We must now introduce PM, or particulate matter. They are particles, solid or liquid, with micrometer dimensions that hang around the atmosphere for a long period of time before being deposited on the ground. It primarily consists of dust, dirt, soot. It can range from tiny nanoparticles in the air to sulfuric acid particles from SOx emissions. Once released into the air, these particles can travel. Weather conditions, wind patterns, and geographic features play a role in their dispersion. There are 2 sizes of particulate matter regulated by EPA. Particles between 2.5 and 10 microns are called PM10. These include pollen, construction and mining dust, mold spores. PM10 particles are easily inhaled and accumulate in the respiratory system. PM2.5 refers to particles that are 2.5 microns or less and include combustion particles, organic compounds, soot, and volcanoes. It is also released from burning candles, incense, indoor gas stoves and furnaces, and activities such as woodworking. They have greater health effects as they can reach deeper into the lungs. Like all air pollutants, PM can result in decreased lung function, asthma, respiratory diseases, non-fatal heart attacks, and increased risk of lung cancer, bronchitis, and heart disease. Many common allergens are also PM. Breathing these particles is especially harmful to infants and aged people as well as pregnant women. Long-term exposure can lead to chronic health issues. The degrading impact of PM on human health is further exacerbated by temperature inversion in winters and at night, due to which PM remains trapped near the ground for days or weeks depending on the weather. A 10 microgram per cubic meter increase in PM 2.5 shortens your life by roughly 3/4 of a year. Little drops of water make a mighty ocean. To counter the menace of air pollution, everyone must contribute as individual effort matters. You can start by planting trees. Rooftop gardens are an excellent solution as they soak up polluted air, reduces temperature of the house, and enhances much-needed biodiversity in urban jungles. Make use of the concept of energy efficiency and home design in the best possible manner. Install energy-efficient appliances and limit their use. Consider installing solar panels on your rooftop to power majority of your energy needs. Avoid long and congested trips on road. Instead, walk, cycle, or use public transport. There are many examples of successful policies that reduce air pollution. For example, Clean technologies that reduce industrial smokestack emissions and improved management of urban and agricultural waste can and must be followed in industry. Even steps as small as installing sulfur scrubbers to power plants and catalytic converts to vehicles greatly reduces the PM concentration in the surroundings as the impact amplifies. There's a lot that can be done in transport as well. Prioritizing rapid urban transit, walking and cycling networks in cities, as well as rail interurban freight and passenger travel, shifting to cleaner heavy-duty diesel vehicles and low-emissions vehicles and fuels, including fuels with reduced sulfur and lead content, can all be employed. For the reduction in already existing air pollution, greener cities and technologies such as green architecture and agriculture and vertical and rooftop farming in cities greatly help. Many cities in EU, such as London and Paris, restrict access to city centers to avoid congestion and aggravation of air and noise pollution. Instead, public transport is incentivized by the city governments to encourage people to leave their vehicles at home. Numerous cities around the world have improved in air quality. For instance, China's megacities, Beijing, Shenzhen, and Shanghai, have massively reduced its pollution levels by heavily focusing and investing in transport, waste management, energy, and industry.